These discrepancies make it important to track what powers our grids as they electrify, in order to make sure it is done in a way that is not harmful to the climate. One of the problems with measuring carbon impacts is that we don't yet have a common taxonomy or standardized set of methodologies to scale decarbonization. Our working group, the Power Systems Data Working Group, seeks to tackle this problem. Our group sits within a larger group, which is called the Carbon Data Specification Consortium, which itself is one of the projects under LF Energy, which is within the Linux Foundation. Our group's focus is on building a unified standard for sharing power systems data. Our sibling working group within the Carbon Data Specification Consortium works to establish a similar set of standards for sharing customer energy data. We believe that a unified power systems data standard would ensure a reliable and trustworthy means for measurement that includes a common set of definitions where possible, that's accessible to those seeking to calculate emissions impacts, and provides a means of comparing systems operations across the world. So the following slides outlines the remainder of this talk, which will actually focus on what we've built, what we've learned, and what we plan to do next with our work related to the standardization of fuel mix and generation data. And we're going to start with what we've built this far, and discuss some users and use cases of the work, and then discuss a little detail what our next steps are for both the working group and the broader Carbon Data Specification Consortium. So the API specification that we've been building is meant to encapsulate all the information necessary for one to be able to calculate the carbon intensity for a given time and location within a power grid. And so in this specification, we focused on 3 types of endpoints. The first is system level data, which includes information about what fuel types and technologies exist within that grid and their related definitions, as well as some information about the grid topology. We then included some resource-specific metadata, such as the location, capacity, and how a given resource connects to others. You can think of a resource as like a power plant, or more aggregated as something that's like an entire kind of region or something like that. We also included endpoints that focus on returning the time series information necessary for carbon intensity calculations to be performed at that location. Our focus thus far has been, in the working group, has been on grid taxonomy and the structure of the grid data itself. In the future, we're planning on building on these standards to establish common methods of calculating grid carbon intensity in all the different ways that it can be calculated. And subsequently, we'd like to also standardize measurements and verification schemes for various decarbonization project types. So evaluating the actual impact of different types of projects that are trying to decarbonize the grid. For the taxonomy portion, the first portion of this work, we decided to lean heavily on AIB's definitions for energy inputs and technologies. There's some significant standard work had already taken place around the naming conventions around different fuel types and technologies. And so most of our work thus far has been on this step 2, which is formalizing the API for sharing fuel mix and generation data. One of the first pieces within that was creating a numerical system for the topological levels of the grid. So we found quickly when we had both US, European, and others in our working group that people name different aggregations of the grid in different ways. And so what we decided to come up with was a numerical system that could be assigned to a certain level of aggregation of the grid, and allow a system operator who's implementing the specification to be able to assign this level to a given name. That way, somebody who's accessing data from a US grid or a European grid could more easily compare information that they're getting. And so that topological system, as well as those endpoints that I mentioned, are we are currently in progress in terms of writing out the actual specification and the details. We're hoping to sort of finish that all up within pretty soon, by the end of the year or in the next quarter. But in addition to that work, something that we found very important was to hand in hand with writing out like a formal specification document, creating a demonstrator that allows people to access the API as we kind of develop it. So that way we can see when we're missing different parts of data, different filters that might be needed, et cetera. And what we currently have now is a live demonstrator that if you can go to that URL that has kind of where we're at so far in terms of implementing the spec with in the API little demonstrator app that we created. And so we're hoping by the end of this year to have both this demonstrator and the spec ready so that people can continue to use it and give us feedback on fields we're missing, different ways that the data should be shared, et cetera. So I wanted to primarily focus on two key user bases for why even write this spec in the first place. And the first one is for system operators who either through volunteering or by being mandated to are trying to provide sufficient information for calculating grid carbon intensity. And the implementation of this spec would ensure sufficient compliance towards calculating grid carbon intensity, as well as a shared data model, which would make it way easier for carbon calculations and comparisons across grids to take place. But another use case that we think is very important is for smaller utilities to be able to share data, especially those that are ahead of the curve with decarbonization. So an example here shows Hibbing, which is a small public utility in Minnesota that's powered entirely by a single clean power plant. And they're a part of MISO, which is an RTO that's got a much higher carbon intensity. Hibbing is unlikely to have real-time data access because they're just a small sort of company. So they don't have a way to easily contribute to the consumed carbon intensity calculations of the region to be able to have a customer there be able to see data that shows that their electricity is coming from a cleaner source than the broader region is. And we'd like our standard to act as a framework for utilities like Hibbing to be able to more easily share their data and have it be inclusive in the calculations of the carbon intensity of the grid in that area. The following use cases would be unlocked through the implementation of our spec, and these are the things that we're hoping this becomes useful for going forward. So the first is carbon accounting, which right now is already in high demand as institutions measure their environmental impact. But secondly, consumption optimization, such as demand response programs, where you can use this carbon intensity information and this fuel mix data to figure out when it's best to shift load in order to reduce your carbon impact. Thirdly, renewable energy project planners can use carbon intensity information to figure out where their projects could make the biggest impact, which grids, which regions. And fourthly, this data is useful for the measurement of electrification and energy efficiency projects, for heat pump installs, for whole home retrofits, to see what is the actual, not just electricity impact, but what's the actual carbon impact of doing those projects over time. And I just like to quickly plug my company, WattCarbon, which falls squarely into use case 4. And so we've built a decarbonization marketplace, which relies on the principles of this M&V work through the Linux Foundation to focus on measuring the impacts of decarbonization projects and allow people to enter into virtual power purchase agreements, not only for solar, but for electrification projects and demand response programs, to allow for people to be able to fund decarbonization that's both additional and verifiable at the hourly level. So here's what's coming up next with our working group and the Carbon Data Specification Consortium as a whole. We're hoping to complete, like I said, the first iteration of our working group's specification and the demonstrator by the end of this year, or hopefully at least by the end of Q1 next year. And starting next year, the Carbon Data Spec Consortium is also planning on kicking off some work around formalizing and defining the different types of carbon intensity calculations, as well as standardizing methodologies around measuring the impacts of decarbonization projects. And that work is planning on kind of going through 2024. So here's some ways you could get involved. So as we build out this demonstrator, we're looking for people who are used to using this energy data to be able to test it out. We've loaded it up with just some small sample data right now from the EIA and NSOE. We are looking for systems operators who are interested in considering adopting our specification, and also primarily looking for people to be involved in our working group and the broader carbon data specification consortium. So our next meeting is November 28th at 11 a.m. And we're looking for anybody who's interested in this work, specifically power data providers, large corporate buyers of electricity, clean energy solutions providers, anybody who is interested in any of this. And to learn more, you can go to that link below. And that concludes my presentation, but I'm open for questions. I'm not exactly sure how this question system works, though. Okay.
Just very simple one. How you can test the API, where you need to go, and how you will test it. Yeah.
Yeah. So essentially there's a link. We have it served up on like a render server right now. There's the best probably way to go to find everything is is this link that I'll share in the chat. It's powersystemsdata.carbondataspec.org. That has the links to everything else sort of within the first paragraph of it. So there's one caveat which is written in there is that it's right now on a free server, so it takes about a minute to load the first time for the actual API demonstrator part. But yeah, and there's not even an API key or anything of that nature because it's just like a little bit of test data. Like I think it's about a week of data from these different sources, and so feel free to play with it as you wish. And importantly, there's so all of this work is attached to some GitHub repositories that you can find through that link as well. There's one for the specification itself called Power Systems Data. There's another one called Power Systems Data API Demonstrator, where the actual code for the demonstrator lives. And so if you see any issues, have any questions, anything like that, feel free to put a GitHub issue up. You know, if you have any changes you'd like to make, feel free to make a pull request. And yeah, again, feel free to join our working group.
Thanks very much for that presentation. I just had a question on whether there's been, I guess, work already or plans to think about how this kind of overlaps with other like other efforts to have common definitions or common like kind of variable naming, I guess in the more broadly kind of energy system space. And I guess I'm thinking about like something that's a bit more high level, like the integrated assessment modeling consortium's kind of common definitions for energy system modeling, which I know in some cases doesn't overlap with what you're doing, but I think in some cases does overlap. And just wondering if there's been any thought on whether there's kind of at some point would be a mapping between there or some kind of alignment in those definitions.
Yeah, absolutely. So that's that we're actually, you know, the naming conventions of these things and the standard stuff is definitely not my forte at all. So you know, things like that AIB standard around fuel types and technologies is something that I at least was informed by a member of NSOE who was part of the working group. And so I think part of this is kind of like grabbing all of those sort of that information together and having it in a place where somebody who's implementing the spec could use those standards and have the working group be the one deciding between if we need to make decisions about which standards to use for specific naming conventions, we would. I know power systems resource as a concept got pulled out of a standard that I forget the name of, but it's in the repo. So yeah, in general, I think that's something that we'd love to kind of keep working on and going for is finding who else is kind of doing this naming convention work and making sure that we're either just referencing them or hashing out things that are maybe disagreements between multiple parties.
Any other questions? I don't think so. All right, let's give it up.
Thank you.